Here's a question for you. How tall is the average human? Now, the answer doesn't actually matter. I don't care about the answer. The question is, how do we know the answer? How do we go about finding out the answer? Now, I'm sure you're thinking, well, I just open up Google and type it in. But someone had to go find out that answer. So how do we find out that answer? Well, this is a question of population versus sample data. The question is actually asking about population. How tall is the average human from all 7.5 billion humans who are alive right now? But that's ridiculous to try and go out and measure every human. So instead, what we're going to do, the way we go about answering this question, is we take samples of humans. So we go out and we randomly sample a bunch of humans. We find a bunch of humans, and then we take one person at random and we measure their height, and then we take a different person at random, and so on for lots of different people. Now, of course, not everyone has the same height, so there's going to be some natural variation in people's heights. So let's say you go out and you measure 100 people's heights, and you get some average, maybe it's, 175 centimeters or whatever. And then you go back and you measure 100 different people, and you get their heights. Do you expect that the average of the first group is going to be exactly the same thing as the average of the second group of people you measured? Probably not. You would expect them to be kind of close, but you're just picking different people at random, so the heights are going to be a little bit different at random. Okay, so this is an example of sampling variability. Sampling variability refers to the fact that different samples from the exact same population can have different values of the same measurement. So it's a bit of a mouthful explanation, but it's basically just like what I explained in the example. So if you measure the heights of a bunch of people and then you pick a different group of people, it's likely that the average height from the first group and the average height from the second group will be different just because you're randomly selecting different people from the same population. Now, this is a really important phenomenon in statistics because it means that a single measurement is a pretty unreliable estimate of something that's happening in the population, particularly when that population has some natural variability. And if you're studying anything in biology, biology is hugely variable. There's so much diversity in biology, but also physics, chemistry. There's variability all over the place, and sampling variability is a fundamental issue in statistics. It's why we need to apply a lot of our statistical methods. So where does this sampling variability come from? Why is there sampling variability? So sampling variability comes from several different sources or several different reasons. One is that I just mentioned, there is natural variation in all sorts of things. Like earthquake magnitudes, there are natural variations, the number of stars in a galaxy, and so on. Sampling variability can also come from measurement noise. If you're measuring the world with measurement devices or sensors that are a little bit noisy or are imperfect, then those sensors are going to give you data that is not necessarily perfect. So there's going to be noise built right into the measurement systems. And then we also have the issue that complex systems have many factors that contribute to them. This is a little bit related to natural variation. But imagine, for example, that we were measuring height while ignoring age. Well, obviously, if you ignore age and you pick people at random, you're also going to pick a bunch of infants and kids and teenagers and adults and old people. And so you're going to find that height varies enormously if you're pooling together people who are 1 year old and people who are 45 years old. And the more complex the system, the more factors there are that can affect the measurements. Again, this isn't bad, it's interesting studying complex systems, but these are sources of sampling variability. And there's also just some randomness. The universe is a wild and unpredictable place, and so random things happen without us being able to control them or sometimes even understand or measure them. So there's natural randomness in the things that we are trying to study. So what do we do about sampling variability? How do we solve this problem? Well, you might have already guessed what the intuitive answer is, which is a great thing to do, and that is to take many samples. That's one of the things we try to do in science, is we don't trust one single point of data. Instead, we try to gather a lot of data. We try to replicate our findings. We try to have other researchers replicate our findings. And so we pull more and more samples together. And the more samples we get, the more confident we can be that we are getting to some underlying truth. This is a phenomenon called the law of large numbers. It sounds very fancy. And of course, we run statistical analyses on our sample data. And in particular, we can compute measures of confidence around our sample estimates. So we compute the average of a sample, and then we can say, not only is the average height of this group 175 centimeters, but we can also compute how confident we are in that estimate. So we can say, we are very, very confident that the average is between 173 and 177 centimeters, or maybe because there's so much variability in our sample, we can say, well, we're only confident to a precision of 15 centimeters.